All right. No, it's not a new lesson. Okay, we gave a lot of lessons this week. It's a question. So, yeah, 2 point sources. This is number 5 on page 460. This is page 460, number 5. It's kind of weird the way it's worded, so just follow along here. Okay, so 2 point sources are 5 centimeters apart. So I'm going to draw a little diagram down here. The distance between them is 5 centimeters. So that's, I'll write it on the margin here. So D is 5 centimeters. Okay. And it says here, a meter stick is placed above the water parallel to the line joining the two sources. Okay. So what that means is the line joining the two sources is that 5 centimeter line that I drew. So I'm going to draw a terrible meter stick here. Okay, whatever, there's a meter stick. It's placed above the water, parallel line joining two sources. Okay, and now it says that the first nodal line is the one adjacent to the central axis. So I'm going to draw in black the perpendicular bisector. Okay, like that. That is not a nodal line. In fact, down the middle, it's never a nodal line. It's always an antinode, okay, with double slit interference. So it says here the first nodal lines. I'm going to draw the nodal lines in red. So the nodal lines sort of go off like this and go off like that. So that's n equals 1 on both sides, the first nodes. Okay. Now what it says is that they cross the meter stick at 35 and 55 centimeters. So let's say this one here, I'll use blue. Let's say that one, that's 35 centimeters there. And this one is crossing here at 55 centimeters. Okay, that's the markings on the meter stick. Now, what else does it say? 35, 55 centimeter marks, each crossing place 50 centimeters from the midpoint joining the two sources. So the crossing points, I'll use a rainbow color, they're saying this distance from here to there, okay, and from here to there, those two distances, those are both 50 centimeters, that one there and that one there. So let's go on the margin. Right away we know that L is 50 centimeters. Okay, because that's what L is. It's the distance from the nodal point, P, right? And the midpoint joining the two sources, which is right down there. Okay, so this is Pn over here also. So there's two nodal points here. All right, now what we need to figure out from this information is what Xn is. So here, I'm going to stick with my black color. That is x1. And this distance over here would be x1 also. Now, between 35 and 55, there are 20 centimeters. Okay, so that means that x1 is 10 centimeters. So I'm going to write that over here. 10 centimeters. And of course, right away, you're going to have to convert all these to meters. So this one's going to be 0.05 meters. This one's going to be 0.5 meters. And that one is going to be 0.1 meters. And of course, n is 1. And what the question is asking for is we draw a diagram. So we did that. And then it says, then calculate the wavelength and speed of the waves. All right, so we're going to use this formula, xn over L equals n minus 1/2 lambda over d. You can solve that for wavelength. I will let you do that because this is for you to practice. Okay, no problem. It's just some algebra there. We got all the values we need except the wavelength. And then to get the speed, so this is like, question 1, question 2, to get the speed, v equals f lambda. They do tell us in the question that the frequency is 6 hertz. So we come back down here. I'm just going to say the frequency is 6.0 hertz. And you get the wavelength, of course, from step 1. So speed equals frequency times wavelength. So just multiply your first answer times 6, and that's it. All right, so that is how you do page 460, number 5. Okay. All right. Hope you're enjoying your weekend. Talk to you soon.